At 11:10 a.m. on April 9, 2026, the structural integrity of the Canadian Pacific Cordillera ceased to be a matter of geological slow time and became a matter of immediate existential survival. British Columbia is currently drowning and burning at the same time, caught in a geophysical pincer movement that has no precedent in the nation's recorded history. In the month of March alone, 2 trillion gallons of water fell across the coast mountains and the lower mainland, a staggering 3,000% above seasonal norms, triggering the most catastrophic flooding event in the Pacific Northwest in over a century. But as the province struggled to keep its head above the rising Lillooet and Fraser rivers, the earth itself revolted. Mount Meager, a massive volcanic complex 150 kilometers north of Vancouver, ended its 2,400-year slumber. The 44th eruptive pulse of this ongoing crisis launched a 250-meter lava fountain into the saturated sky and blasted a jagged ash plume 5,000 meters into the flight paths of the Pacific Corridor. The province of British Columbia has declared a state of emergency, mirrored by federal disaster intensives from Public Safety Canada. This is not a weather event, and it is not a volcanic event. It is a coupled systemic collapse. In a single weekend on the outskirts of Abbotsford and North Vancouver, 200 people were plucked from rooftops by CH-149 Cormorant search and rescue helicopters as floodwaters turned residential streets into Class 5 rapids. In the town of Pemberton, a historic secondary school, the heart of the community, has been silent since March 19th. 96 of its classrooms have been surrendered to the mud and silt. They are gone, likely forever. Across the province, the infrastructure damage to regional airports and the sea-to-sky corridor has already exceeded 245 million Canadian dollars. In the shadows of the erupting massif, residents in the upper Squamish Valley are reporting softball-sized chunks of pumice and volcanic rock raining down on their properties, burying homes under 25 centimeters of hot tephra. Sulfur dioxide emissions from the Meager vent have hit 28,000 tons per day, concentrations so high that they have choked the air quality for the entire sea-to-sky corridor and parts of the Sunshine Coast. But there is one detail that should alarm you more than the drowning schools or the falling rock. On April 8th, 24 hours before the main vent breached, the Squamish-Lillooet Regional District Chair signed an emergency proclamation with language never before used in Canadian governance. It cited concurrent volcanic and hydrogeomorphic hazards. He was bracing for a collision of a catastrophic low-pressure system and the magmatic ascent. The next morning, the mountain blew. 300 students at a local elementary school were evacuated in minutes as gray ash began to blot out the midday sun. Highway 99, the singular artery connecting the interior to the coast, was severed. Scientists at Natural Resources Canada say the massif is reinflating at a rate that suggests the next pulse is only days away. British Columbia is not recovering. It is trapped in a disaster that is actively reloading. The chronology of this dual-threat catastrophe is a masterclass in geophysical system coupling. It began not with fire, but with a relentless, suffocating influx of water. On March 10, 2026, the first Pacific siphon, a massive stalled atmospheric river, locked itself over the British Columbia coastline and refused to budge. For 6 days it hammered the coast mountains with a deluge so intense it bypassed the standard meteorological scales. Wind gusts at the peak of Whistler Mountain were clocked at 217 km per hour, while the lower elevations were subjected to a constant, high-pressure hydraulic assault. On March 13th, the Vancouver International Airport Weather Station recorded 140 millimeters of rain in a single 24-hour window, obliterating a daily record that had stood for 75 years since 1951. By the time the first system began to taper on March 16th, rain gauges in the Pemberton Valley and throughout the Squamish-Lillooet Regional District showed a cumulative total of 1,575 millimeters. The ground was no longer a solid medium. It was a pressurized sponge. Then came the rain bomb. On March 19th, while the province was still reeling and provincial engineers were struggling to assess the stability of the sea-to-sky highway, a second, even more concentrated atmospheric river slammed into the lower mainland. This system parted itself directly over the North Shore Mountains and the Fraser Valley, dumping 50 to 100 millimeters of rain per hour. By March 20th, flash flooding had transformed the North Shore into a series of debris flow channels. 200 high water rescues were conducted in a single weekend. The Fraser River, already swollen to spring freshet levels in the middle of March, began overtopping dikes near Abbotsford. But beneath the surface of the Mount Meager Massif, a much more dangerous process was accelerating. At the Natural Resources Canada Seismic Monitoring Hub in Sydney, technicians began detecting a shift in the mountain's baseline breadth. On April 1st, GNSS stations mounted on the volcanic peaks of the Garibaldi volcanic belt recorded a sudden 12 cm horizontal offset. This wasn't the slow creep of tectonic plates. It was the rapid expansion of a shallow magma reservoir. At 7:22 a.m. on April 4th, 2026, seismographs located a swarm of earthquakes at a 12-kilometer depth focused directly beneath the Meager complex. The waveform was distinctive, harmonic tremors, the rhythmic hum of pressurized magma forcing its way through the brittle ductile transition zone of the Earth's crust. The geophysical trap was now set. The trillions of gallons of rainwater that had saturated the massif's porous volcanic rock and unstable glacial till had increased the pore pressure within the mountain's hydrothermal system. This massive weight of water acts as a lid, but as the magma rises, the heat flashes that groundwater into superheated steam. On April 8th, the regional district chair for Squamish-Lillooet, David Kimo Alamita, signed an emergency proclamation that will be studied by disaster researchers for decades. It cited concurrent volcanic and hydrogeomorphic hazards, an admission that the state was fighting a war on two fronts. He told local media that the province was bracing for the collision of a low-pressure atmospheric system with a high-pressure magmatic ascent. At 11:10 a.m. on April 9th, the mountain breached. The north vent of the Mount Meager complex cracked open with a roar that was heard as far away as Lillooet. This was not a slow lava flow. It was a violent decompression. Within 90 minutes, a lava fountain reached 244 meters, nearly the height of a 70-story skyscraper, pulsing against the gray, rain-heavy sky. The Geological Survey of Canada, GSC, and the Pacific Region Volcanic Ash Advisory Center tracked the resulting ash plume as it surged to 4,800 meters above sea level, directly into the transcontinental flight paths. The data coming back from the field is terrifying. While the rain continued to wash out culverts, the volcano began raining solid rock. In the upper Squamish residential pockets, 10-centimeter thick layers of tephra, volcanic glass and stone, buried vehicles and collapsed the roofs of outbuildings. The most critical artery, Highway 99, was sealed between mile markers 41 and 65, cutting off the interior from the coast. For 8.5 hours, the Earth purged itself of 28,000 tons of sulfur dioxide. To put that in perspective, that is roughly 4 times the daily SO2 output of the entire Canadian industrial sector, all concentrated into a single, narrow mountain corridor. The air became a toxic slurry of sulfuric acid and volcanic ash. Even more chilling is the data from the USGS equivalent tilt meters monitored by NRCAN. By the evening of April 10th, despite the eruption pausing, the ground didn't settle. Instead, the tilt meters recorded a 2.1 microradian recovery. The magma chamber isn't emptying, it is refilling from a deeper source at a rate that suggests the system is reloading. The official statement from the GSC was blunt. The rapid return of inflationary tilt and strong thermal anomalies from the vent indicate that another lava fountaining episode is likely. Episode 44 was just the beginning. The pressure is building, the water is still falling, and the mountain is only halfway through its opening act. To understand the sheer magnitude of the catastrophe unfolding in British Columbia, one must look past the terrifying visuals of lava fountains and look at the raw, unforgiving data. The University of British Columbia's Mesonet weather stations, in coordination with Environment and Climate Change Canada, have just finalized the rainfall totals for March 2026. The number that came back has effectively rewritten the Canadian record books. 2 trillion gallons of water fell on the province's southwest corner in 31 days. To visualize that volume, it is enough water to fill 3 million Olympic-sized swimming pools, or to cover the entire city of Vancouver in a column of water nearly 20 meters high. Statewide, or rather province-wide, rainfall averaged 463 millimeters for the month, 2.6 times the normal March average. March 2026 is now officially the wettest month in British Columbia's recorded history, eclipsing the devastating atmospheric river events of November 2021. But the rainfall total is merely the catalyst for a much more dangerous geophysical process. This is the trap of coupled systems. The soil across the coast mountains cannot absorb another drop. Every hillside, every drainage channel, and every culvert is at absolute capacity. When the third atmospheric river arrived in early April, the water didn't soak in. It acted as a lubricant. Scientists at the Geological Survey of Canada, GSC, have long warned that Mount Meager is the most unstable mountain massif in Canada. It is a crumbling edifice of hydrothermally altered rock, held together by ice and internal pressure. By saturating this already weak structure with 2 trillion gallons of rain, the local geology was primed for a structural failure of a different kind. Historically, Mount Meager has a violent pedigree. In 2010, it produced the largest landslide in Canadian history, 48 million cubic meters of debris that dammed the Meager Creek and the Lillooet River. In 1915, another massive collapse buried portions of the valley. But those were cold climate events. What is happening in 2026 is a hot collapse. The rising magma, detected by NRCan's borehole tilt meters, is not just pushing against rock. It is pushing against rock that is fully liquefied by months of record-breaking rain. This creates a steam drive effect. As the 1200 degrees Celsius magma rises, it flashes the groundwater into superheated steam, causing the mountain to literally explode from the inside out. Dr. Marcus Hill, a lead volcanologist at Natural Resources Canada, described the current state of the Garibaldi volcanic belt in a recently leaked internal memo. We are no longer looking at isolated events. The extreme hydraulic loading from the March storms has likely altered the lithostatic pressure on the shallow magma chamber. We are seeing a direct correlation between rainfall intensity and seismic bursts within the massif. The mountain is reacting to the water, and the magma is reacting to the mountain's instability. It is a cascading failure of the crustal system. This leads to the most terrifying forecast model in the GSC's current arsenal, the lahar. A lahar is a volcanic mudflow with the consistency of wet concrete and the speed of a freight train. With 10 inches of fresh volcanic tephra now sitting on top of slopes that are already 100% saturated, the next heavy rain, forecast for this coming Monday, will transform that ash into a lethal slurry. Unlike the 2010 landslide, which was a singular event, the 2026 crisis is cyclical. The volcano erupts, coating the landscape in loose rock. The atmospheric rivers return, washing that rock into the river systems as lahars. The riverbeds rise due to sedimentation, causing even minor rain to produce catastrophic floods. The twist that has caught provincial planners off guard is the reloading mechanism of the Mount Meager plumbing system. Typically, an eruption of this scale would relieve pressure for decades. However, GNSS data shows that the Pemberton Valley floor is sinking while the mountain summit is rising, a clear sign of magmatic withdrawal from a deep source to a very shallow one. The magma isn't just sitting there, it is being pumped in. The GSC's latest report suggests that episode 44 was not the climax, but a clearing of the throat. The geophysical models indicate that the magmatic flux is currently 400% higher than it was during the initial breach on April 9th. The system is pressurized, the fuel is being replenished, and the lid of the mountain has already been compromised by the wettest March in 100 years. The clock is not just ticking for the residents of the sea-to-sky corridor, it is accelerating. Behind the staggering geophysical data lies a human geography currently being erased. On the morning of April 9th, Dr. Elena Tremblay, a senior field seismologist with the Geological Survey of Canada, was at a temporary monitoring station in Pemberton when the mountain breached. She describes the sound not as an explosion, but as a low-frequency tearing of the Earth's fabric, a sound that vibrated the very marrow of her bones. We watched the telemetry spike into the red, she recalls, and then the sky simply turned a bruised metallic purple. It wasn't just ash, it was the smell of the Earth's interior, a sharp, acidic sulfur that immediately triggers a primal flight response. As the north vent of the Mount Meager complex fountained, Tremblay's team had less than 8 minutes to coordinate with local RCMP to begin the evacuation of the Upper Squamish and Lillooet River valleys. The human toll is concentrated in the wreckage of infrastructure that was never designed for a multi-front war. Consider the case of Pemberton Ridge High, a structural pillar of the community for nearly a century. On March 19th, as the second atmospheric river, the Rain Bomb, stalled over the valley, the school's drainage systems were overwhelmed by a combination of glacial silt and 100 millimeters of hourly rainfall. The school has not held an in-person class since. Of its 124 classrooms, 96 have been declared a total loss, their foundations undermined by the liquefied soil and their interiors filled with a meter of toxic mud. The British Columbia Ministry of Education has tallied 171 million Canadian dollars in damage to public schools across the region, with Pemberton Ridge alone requiring 37 million Canadian dollars for a reconstruction that may never happen. For the residents of the Upper Squamish Valley, the nightmare is dual-layered. The Miller family, who have farmed the valley for 3 generations, woke on April 10th to find their livelihood buried under 25 centimeters of volcanic tephra. The rain was still coming down in sheets, Sarah Miller told local reporters, but instead of water, it was falling as this heavy gray sludge. The weight of the wet ash collapsed our barn roof in minutes. We were trapped between a rising river at our front door and a raining mountain at our back. They are among the thousands currently displaced, housed in emergency shelters in Whistler and Squamish, that are themselves struggling with power fluctuations and failing telecommunications. The logistics of this crisis are uniquely Canadian and uniquely terrifying. Canada is a nation of vast distances and narrow corridors. British Columbia sits 3,000 kilometers from the manufacturing heartland of Ontario and Quebec. There are no alternative highways when the sea-to-sky, Highway 99, and the Trans-Canada, Highway 1, are severed simultaneously. When the Vancouver and Abbotsford airports sustained 245 million Canadian dollars in flood and ash damage, the province becomes a geographical island. There is no driving supplies from a neighboring province when the mountain passes are turned into debris flow chutes. On April 9th, Prime Minister Justin Trudeau approved a major disaster declaration, a move intended to unlock billions in federal funding through the Disaster Financial Assistance Arrangements (DFAA). On paper, this is a lifeline. In reality, the mechanism is seizing up. A protracted parliamentary stalemate in Ottawa over the latest federal budget has left Public Safety Canada's emergency reserves at an all-time low. The 26 billion Canadian dollars appropriation bill required to replenish the DFAA is stalled in committee, meaning that while the disaster is officially recognized, the actual flow of capital is a trickle. As the federal government bickers, the physical environment continues its assault. The 28,000 tons of sulfur dioxide emitted during the April 9th fountaining episode have created a dense volcanic smoke, VOG, that has drifted south into the Fraser Valley and the Metro Vancouver area. The BC Department of Health has issued emergency respiratory advisories, warning that the combination of high humidity from the ongoing rains and volcanic particulates is creating a chemically active atmosphere. In the Cowichan and Kona equivalent districts of the coast, residents with pre-existing conditions are being told to seal their homes with plastic sheeting, a grim echo of Cold War-era protocols now deployed against a tectonic enemy. The crisis is now reloading. At the Meager Valley School of Arts and Sciences, 300 students were forced to leave behind their belongings as hot rock fell from the sky, a scene Vice Principal Chris Kim Gates described as apocalyptic. These children are now part of a displaced generation, watching their communities buckle under the weight of three simultaneous disasters: the flood, the fire, and the systemic failure of the institutions meant to protect them. The question being whispered in the hallways of the GSC in Ottawa and the emergency bunkers in Victoria is no longer how to fix the damage, but how to survive the next 72 hours. The tilt meters on the Massif are climbing again. The magma is moving. The sky is still grey with rain. And for the 5,500 people evacuated from the North Shore and the thousands more cut off in the interior, the isolation is absolute. As the sun sets on Monday, April 13, 2026, the temporary silence over the Mount Meager Massif is the most terrifying data point of all. In the world of volcanology, silence is rarely a sign of peace. It is the sound of a system holding its breath. The latest INSAR satellite passes, processed by Natural Resources Canada, shows that the summit of the mountain has moved another 4 centimeters upward in the last 6 hours. The reloading phase is nearly complete. The magma reservoir, fed by a deep-seated plumbing system that scientists are only now beginning to map in real time, is once again approaching its breaking point. And this time, it is not just the mountain that is vulnerable. It is the entire economic and social heart of Western Canada. What happens next is a matter of geophysical inevitability. The forecast from Environment and Climate Change Canada calls for an additional 150 millimeters of rain over the next 48 hours as the tail end of the third atmospheric river sweeps across the coast mountains. The ground, already saturated by 2 trillion gallons of water, has reached its limit of cohesion. Every hillside is a potential failure point. If the next eruptive pulse, episode 45, is larger than the last, it could trigger a catastrophic sectoral collapse of the mountain's southern flank. This would not just be a landslide, it would be a hot lahar, a high-speed torrent of boiling mud, volcanic ash, and glacial meltwater surging down the Lillooet River Valley at 100 km per hour. The consequences would ripple through the Pacific Gateway. The Port of Vancouver, Canada's largest and most vital maritime hub, handles over 300 billion Canadian dollars in trade annually. It is the throat of the Canadian economy. Elias Chen, a lead logistics coordinator for the port, warns that the system is already at the brink. We are seeing the silting of the Fraser River Delta at an unprecedented rate due to the upstream volcanic runoff, Chen reported in a briefing to Public Safety Canada. If the riverbed rises by another meter, the deep-sea vessels that carry Canadian grain and potash to the world will be grounded. We are looking at a total maritime paralysis. The rail lines, the CN and CPKC arteries that bind the country together, are similarly exposed. They run through narrow canyons that are now effectively drainage ditches for a volcanic crisis. One major lahar could sever Canada's supply chain for months, if not years. The human tragedy is still unfolding in the displacement camps. The 300 students from the Meager Valley School of Arts and Sciences, now scattered across temporary shelters in the interior, are living through a lost semester that has no clear end date. Their school is a tomb of silt and ash. For them, and for the thousands of families along the sea-to-sky corridor, the Canadian dream has been replaced by a Canadian survival reality. Dr. Amara Singh, a senior research scientist at the GSC, knows that we are entering a new epoch of geological instability. We used to think of these events, floods and volcanoes, as distinct chapters in a textbook, Dr. Singh stated. But 2026 has taught us they are part of the same sentence. The water weakens the rock. The rock allows the magma to rise. The heat melts the ice, and the cycle begins again. We are not just watching a disaster, we are watching the Earth's crust find a new, more violent equilibrium. The financial fallout is equally staggering. With the Federal Disaster Financial Assistance Arrangements, DFAA, still stalled in Ottawa, the burden has fallen on the province and local municipalities. British Columbia's credit rating is under review, and the estimated 1.2 billion Canadian dollars needed for immediate infrastructure repair is likely a fraction of the final bill. When a G7 nation cannot provide the liquidity needed for its own survival, because its political systems are slower than its geological ones, the risk profile of the entire country changes. The data does not lie, and the data says that the clock has restarted. The tilt meters on the Massif are no longer rising slowly, they are spiking. The seismic hum of the harmonic tremors has returned to the 15-kilometer depth mark, moving upward. The sulfur dioxide levels are once again beginning to climb, turning the morning mist into a caustic haze. Somewhere in the upper Squamish, the 300 students are waiting for a sign that it is over, but the mountain is giving them the opposite. Hawaii's dual disaster was a warning, but British Columbia's collision of fire and water is the realization.